Alright, for this next video we're just going to work with a couple of examples, f of x and g of x, that are both rational functions, and just work through a bunch of example problems here. So this first one, I'm going to try and find f of g of 1. To do that, another way to write it is to put the f function on the outside, the g function on the inside, and the 1 is the input. Okay, so I need to first find g of 1. So g of 1 is going to equal 2 over 1, which of course reduces to 2. So that becomes my new input into the f function. So this g of 1 becomes 2. And we'll be left with f of 2. Okay, now when I write this out, the 2, being the input, goes in for the x's in the f function. So I'm going to have 2 over 2 plus 2. Notice how each of the x's in the f function again becomes the 2 that we're inputting, which happen to be the output from the g. Then we simplify this down. This will become 2 over 4, which reduces down to 1/2. So f of g of 1 is equal to 1/2. Okay. Next example, let's run through g of f of negative 3. And again, we'll take a similar approach to this, where the g function now is the outer function, g of, and then the f is the inner function, so f of, and negative 3 is our input, g of f of negative 3. Okay, so when we calculate this, we're going to want to first find f of negative 3. So I'll take that off to the side. F of negative 3 is equal to negative 3 over negative 3 plus 2, which is negative 3 over negative 1, or simply 3. That 3 becomes the input into the g function. So we're really looking at g of 3. And when I plug that 3 in to the g function, I'm going to get 2 over 3. Okay, now that really doesn't reduce, so that is the final answer. I'll write it in blue. Represent our final answer of 2/3. Okay, now let's try a third one. Let's look at f of g of x. So this one I'm not plugging in a specific value. So f of g of x. No specific x value, just a variable, keeping this as a function. So again, we're going to start this off by writing the f function on the outside. Now in place of the x's here, I'm going to replace those with an empty set of parentheses, just so you can see where everything is getting placed. Okay, so now you can see that the x's become empty sets of parentheses. Now the g is the inner function. So the g is what's going to go into those sets of parentheses. And this will become 2 over x and 2 over x. Okay, so I'm inserting the function g into the function f. Now we need to simplify and make this actually look nice, otherwise I've got a complex fraction here, and no one wants fractions inside of fractions. So we're going to have 2 over x, and then here we have 2 over x plus, now this 2, I'm going to write it in fraction form, 2 over 1, and then we can get a least common denominator out of this. The LCD here is x, so I'm going to multiply top and bottom by an x. That will give us 2 over x all over 2 over x plus 2x over x. And when I add the two common denominators, 2 plus 2x all over that common denominator of x. So what I'm doing is I'm trying to simplify this. I combine the two fractions on the bottom, and now I'm going to use a copy dot flip. Remember, the big fraction bar is a division, so it's fraction divide by another fraction. And so to do that, we're going to copy the top fraction, and instead of dividing, we're going to multiply by the reciprocal of the bottom fraction. Well, right away I notice that the x's, there's a factor of x that is common to the top and the bottom. I'm going to cancel those out. And then I'm going to do a little factoring. I've got a 2 on top. I also have a 2 plus 2x on the bottom, but notice that you could pull a 2 out of those. So you get a 2 times 1 plus x. I then have a common factor of 2 on the top and bottom that can cancel, and this will end up as 1 over 1 plus x. Okay, so there's my final function, f of g of x. What is interesting about that function is that if I were to go back, notice up here I have f of g of 1. If I were to take that 1, and instead of just sequentially plugging it into g and f, if I just go down and plug it into this new function, I should get the same output. Okay, so for part D, let's do that. Let's do f of g of 1 again, but using this new function. I get 1 over 1 plus 1. And in that case, I get 1 over 2. Which is the same thing we got before, right? 1/2, 1/2, same thing. Okay, now finally, the last thing I want to look at is the domain of a composite function. And typically the domain of a composite function is the domain of the new function. So in our case, if I do f of g of x, the new function, we found that a couple problems ago, is 1 over 1 plus x. And you all know how to find the domain of a rational function at this point. You take the zeros of the denominator, subtract your 1, you get x equal negative 1. The zeros of the denominator then get excluded from the domain. So our domain is going to be x such that x is not equal to negative 1. Now on your MyMathLab homework, you're going to see some domain problems. You're going to see a bunch of compositions with numbers and some compositions with variables. You'll need to know how to address all of those.